Yeah.
So I think we'll throw it over to Adriana, who I assume will be the first to welcome our new robot overlords.
Possibly. Yeah. So robotics is this interesting space. I think everyone sort of thinks they're coming, but I think we'll see as we move forward they're actually already here. So we're talking today about how robots are going to change our cities. I should probably worded it, how will robots change our cities, with a question mark at the end. I'm going to throw a few things out there that I know that are happening that I believe are relevant, and I think between the policymakers and the people that understand the intersection of technology, culture, and people, I think there'll be a great discussion here. I am the founder of the Get Your Bot On Robotics Hackathon, and if you want to find us, that's how you find us. We run a so far yearly hackathon, which is a build a robot in a weekend type of event, or build a prototype anyways in a weekend type of event. We very much believe in interdisciplinary collaboration, so we have artists, we have engineers, we have designers, we have subject matter experts in whatever theme area we're working on coming together to actually build a robot. And we also reach out into the network of hardware creators and try to bring new and interesting hardware to the table. So this past September we had, for example, XYZ Interactive providing gesture recognition sensors. Muse, the brain sensing headband, brought their technology to the event, just to sort of give people an opportunity to try out and test and see what they can come up with these new types of hardware. We've run the Hackathon event 3 times. In 2012, we didn't have a theme. I'll show you some of the robots from that event. In 2014, we did Aging at Home, and we were hosted at the Ontario Science Centre. And this September, we picked a theme more broadly of healthy people and environments. We've never done something specifically around civic tech or around cities, and certainly it's something to consider for future events. Just really quickly, because I want to give you a sense of the types of people that join us and the types of things that they build. Now, the robots you see here are extremely primitive. Like, we're talking what you can build in about 36 hours. We do provide all of the hardware they need to build. We provide tools like 3D printers and laser cutting, and also soldering and hand tools and all the things that you would need to really just hack something together. And especially, we provide the mentorship. So we had this time 19 mentors, ranging from hardware, electronics, software, right through to subject matter experts that know their space and came to facilitate the idea development. And so here we have Stephanie Hutka, who's a neuroscientist, and Ross McKegney, who's the founder of Verold. This is the first year we ran the hackathon, they'd never touched hardware before, and they built Lady Sterling. Lady Sterling is a robot that's supposed to mimic the human auditory system. So Stephanie's work is around auditory systems, and she wanted to explore this idea of, as you age, in a crowded, noisy room, it becomes very difficult to filter out channels of sound. And they played with microphones and proximity sensors to see if they could create some model of how the human auditory process works in order to filter out different channels of sound. And so then in 2014, Stephanie and Ross came again, and they had another team member, and this is the start of SnakeBot. And Stephanie's idea this time was looking at what happens when you suffer a stroke and it wipes out the part of your brain that is responsible for speaking. The part of your brain that's actually responsible for singing can remain intact and can be retrained to help you speak. And so what SnakeBot would do, like if you ask the person a question, SnakeBot would sing the answer and prompt the person to sing with them until the person could actually speak the answer themselves independently. I don't have a video of this, unfortunately, but I'll try to post something in the next little while. This was Please Touch. This is Carrie, and I'm blanking on her name. I'm so sorry. So Carrie is a dancer, and Laura is a massage therapist, and they built this basically a sex ed robot for the blind. So it would respond to touch with different types of tactile and auditory responses for people who couldn't see. So you can see, like, the ideas just are so wide-ranging and creative, and the teams that come together are extremely diverse and not necessarily your typical software, hardware engineers that might be going to a technology hackathon. This was Instagram-on. They were looking at challenges for the elderly when they receive pictures and they can't print them out, and that's their usual mode of enjoying photographs. So it was a robot that would receive the pictures and then print them out automatically for them, the ones that they chose. So it had some touch screen. So this one in particular perhaps stretched the imagination of what a robot is, but certainly would qualify as a robot. And then we had, obviously, robotic pets, which are often the first place people think of when they're developing robots. And then this was a paper flame-throwing robot. The team behind this one wanted to explore inexpensive tools and technologies that they could build robots for education, or that they could build a kit that kids could, with scrap paper perhaps, build a robot. So they were playing that. The flame throwing was, I think, part of the pizzazz of the presentation, and somehow got past all of our safety checks in a post and beam type of place like this. So yeah, that was a bit of an oversight, but lots of fun. So you can see the ideas that come together. We do have roboticists, but we also have people who come from all different areas coming and actually building together for the weekend, and that's very important to us. And so we define robots extremely broadly. So basically a robot has to be able to take input from the environment, either through sensors or human input or data or other robots. It has to be able to do some computation on that, either through a microprocessor or a microcontroller, or a simple logic circuit, and sometimes that might involve artificial intelligence and machine learning, and sometimes it may not. And then it needs to be able to do something in the physical world, to move in some way or actuate in some way. And many of us have grown up with these images of robots that inform our sort of expectation of what the coming robots are going to be like, and where we're sort of going with them. And Baymax, the movie that came out, I guess, last year, really presented some very interesting concepts in robots, both for Baymax, a sort of social robot for care, but also around swarm robots and some other types of robots that you see happening in the lab that they talk about. The Star Wars robots, which as a child they kind of inspired me. Wall-E and Rosie. I mean, we even had these ideas of robots that would do all the work we didn't want to do way back in, I'm guessing it was the 50s when the Jetsons were on TV. And of course, the Terminator. So these ideas of robots that we have from popular images. And so, of course, before there was the Google self-driving car, if any of you are children of the 80s, you might remember KIT. Remember KIT? Yeah. KIT was the self-driving car and saved Hasselhoff's butt numerous times from many, many challenges. I mean, he was not just a self-driving car, he was also the brains of the operation too, I think. So, yeah, so before the self-driving car, there was KIT. And I think, so those are our images from popular media, but these are things that we already have among us. That's Baxter up there with the red arms. Baxter is by a company named Think Robotics, Ronnie Brooks' organization. And so what makes Baxter special was not only its price point, I think it's got an entry price point of about $20,000, but also what they've done in terms of interface and training. So Baxter is a user experience, user design innovation more than anything. So you don't have to have any technical skill in order to be able to program Baxter to do a task. Somebody right from your line, if you're in a manufacturing facility, can just pick and place his arms, and he learns as you teach him. So that's a really interesting innovation. And the face is sort of part of making the robot approachable. So this whole area of collaborative robotics is really exploding. The middle one is Nip. It's a toy. It actually, XYZ Interactive's technology is in there, but like sub $100, and this thing can read your gestures and will respond to your gestures. So the price of some of these sensors is really dropping amazingly, and that's having huge impact on what can be built at an affordable price point. Of course, the Google self-driving car that everybody's talking about, we talk about it in my class, and every time that damn car has an accident and everybody's freaking out. But as I understand it, at least as Google will say, many of the accidents are actually caused by the other drivers who are driving themselves. So there's some debate there. Down here, there's Kiva Systems, which runs Amazon's warehousing operations. They were purchased by Amazon a number of years ago and are really part of Amazon being able to deliver those products within the time frames and at the price points that they are able to. Roomba's been around forever, but what's interesting about Roomba is they, in some sense, have also made themselves a bit of an innovation platform. So you can buy a Roomba and you can build on top of a Roomba, and they've sort of made it an open platform. So you can do wayfinding with a Roomba, but put your own stuff on top of it, and really quickly create things with autonomous robots. And then, of course, nobody really thinks of things like Nest and other IoT things as robotics, but they are. I mean, your Nest takes information, it reads your behavior, it starts to learn from your behavior, and then it controls your HVAC system, right? I mean, that it's actuating in the physical world, and I'd argue that a lot of IoT implementations are actually robotics. We just don't think of them as such. We were talking before the session about what's happening in Toronto. There is actually quite a bit of activity in this space in the Toronto area. I think everybody's really focused on what's happening in the Valley and south of the border primarily, but there's quite a bit going on, especially around healthcare and staying at home and robots to help you stay at home longer. That's Synaptive Medical's neurosurgery robot, so it helps surgeons do their very, very fine and very, very long operations. You can imagine if you're a neurosurgeon, as you get tired, or even if you're a little bit shaky, you're off for a day or whatever, a robot can actually work a lot of that that variability out of the motions. So even though it's a remote controlled kind of thing, it actually has a lot of intelligence in it to work some of that out. This is Bionic Labs exoskeletons. Primarily, as far as I understand, primarily for people with mobility issues and lower body paralysis as well. And then this is Brian. So the Institute for Robotics and Mechatronics at the University of Toronto does a lot of work around social robots for in the home, and looking at how robots can help you take care of yourself, help you stay at home longer, help also in therapy, so help you play games that would keep you sharper longer, as if you are on your own and don't have someone who can do that sort of day-to-day care. So there's lots of interesting stuff happening, and this is just a really, really tiny snapshot of it. And there are lots of interesting robotics specialties as well. So we've got people working on robots and emotions, robots that can, there's even robots, they're studying how robots can tell jokes. Biomimetics and robotics, so that's the cheetah robot that won the DARPA challenge a while back. I think a lot of people, the sort of Mars rover types of robots are obvious robotics applications, but then, even swarm robots, tiny robots with very limited capability and intelligence, but that work collaboratively, independently collaboratively to accomplish tasks. And there's lots of research going on in these areas. So sort of to give you the big snapshot, and now sort of dig into specifically around cities and the ones that I think might be relevant. And certainly if I've missed something, please add in. So the question is, how will robots change our cities? And like I said, I don't have the answers, but I can throw a few things out there. And so today I kind of picked specific examples of robots that affect sort of these four areas: transportation, commerce, jobs, and broadly daily living. So if you think about transportation, the obvious one is the Google self-driving car. But I'm not sure if you were aware, this is a picture of Carnegie Mellon's huge robotics lab. Carnegie Mellon has for many years been a leader in robotics, and in about late 2014, Uber went and pretty much hired the whole lab at salaries that no academic institution can afford. Why would Uber buy a robotics lab? It's very interesting. And then there's been all kinds of work around self-driving public transportation. And so some of the questions that might arise in terms of transportation, when you overlap transportation and perhaps collaborative consumption, the sharing economy, what happens? Will people already share vehicles? Will we share even more? Will we ever even own a vehicle anymore if that vehicle can drive itself to come and get us now? And that's one of the conveniences of having your own vehicle, is because it's right there, you can just jump in it at any time. If that doesn't even need to happen anymore, what happens there? And then what happens when an organization like Uber starts doing self-driving vehicles, and they're thinking about getting into all kinds of new business models like delivery, that kind of thing. What happens to public transportation when the vehicles are self-driving and robotic? What does that mean for access in very far remote areas? If you live out in Scarborough, and the vehicles self-driving, does that mean we have better public transport because we can make it smaller, more adaptive? And I don't know what the answers to all of that are. Perhaps Joey's and the city's been thinking about and looking at that. I'm not sure if you were aware, but I think is it next month that the pilot program starts around self-driving vehicles? I think it's in January. There's a pilot program around self-driving vehicles. So you very well may be driving beside a self-driving vehicle on the 401 come January 1 in Ontario. So it's very, very interesting. And I think Norian just did a piece on the weekend, a very short piece on it, which is interesting. But that it's all the way from, it's the technical testing of those vehicles, but it's all the way through to the permitting, who will be allowed. In this case, you have to have someone actually behind the wheel, so it can't be completely autonomous. Somebody has to be behind the wheel. So what are the implications? What are the implications for driving under the influence? We were talking at the dinner table on Sunday evening. If I'm drunk and I'm driving behind a wheel of a self-driving vehicle, is that still a ticketable offense? Will you be able to tell? Because now the vehicle's probably correcting for me. So it's very interesting, very, very interesting challenges coming up, and very interesting things that we need to think about. I mentioned Amazon's purchase of Kiva, and so those little things. So if you think about what are people good at and what are robots good at, so I guess Amazon recognizes, so the whole gripping problem is a big problem for robots, right? It can't grip very easily, especially when things are not lined up properly. So say you've got a bin of product, actually picking is a problem. So the gripper problem makes it difficult for them to roboticize the whole thing. But now, if they've got a human picker standing on a platform, those robots can bring all that product right up to the person, so they don't waste time traversing the entire factory or the entire warehouse in order to find all the product that they need to pick and place. And so what are the implications? And I think we're already seeing retail really suffering, like physical brick and mortar retail is really struggling, trying to figure out what their model is to respond to e-commerce. This really makes e-commerce. So first of all, if they can pick it and pack it and ship it to you inexpensively, it brings the price down. Now add drones, and they're talking about like delivery within a half hour by using drones. So what are the implications for our cities? You walk down Yonge Street, all your storefront stuff is retail. What happens to those places and those areas when retail is struggling to survive? And I think that's worth thinking about from a planning perspective. I think there's sort of employment things to think about, and not just sort of the like, you know, we're worried about robots taking our jobs, because I think there's also a flip side. So I talked about Baxter and the whole area of collaborative robots. So collaborative robots are robots that are able to work with people, and in a manufacturing environment, the challenge is that it needs to be safe, right? If I'm working side by side with a robot, and it's like a 400-pound robot, and that arm swings and whacks me, that's an issue, right? And I think, and so researchers are trying to figure out how you make robots in such a way that they can collaborate with people in real time on the shop floor. But what does that mean in North America, where already we're struggling to compete with wages in other countries that where wage rates are very, very low? Well, some people are talking about the fact that in some sense this could repatriate some of that manufacturing. That we could now, in terms of small runs, start to see that there's possibility that we can keep some of that small run stuff here and possibly repatriate. And there's a huge debate in the Internet of Things space. If you're watching and paying attention, if you're in the Internet of Things space, the wearable space, everybody's asking, when are you going to go to Shenzhen to manufacture? Well, the reality is it only is worth it to manufacture overseas once you hit like a fairly substantial volume. Otherwise, between time difference and the cost of going back and forth and getting over that sort of cultural and language barrier, there's a real case to be made for local manufacturing, and I think that's very exciting. So it's not just about whether or not everything's going to be automated, but whether or not there are opportunities to perhaps repatriate some work. This is a Factory in a Day project that's being funded by the EU, actually. So they're looking at ways they can build these types of collaborative robots, but in ways that you can get the factory up and running within a day, so that you can be very flexible. And then that comes with all kinds of new business models as well. So if you think about if you can get it up and running in a day, think about an organization, a small or medium-sized organization that can't typically afford to automate a whole line. They might be able to lease for a short period to complete a run. And so they're all new business models that come when you can be this flexible and this agile with the technology itself. So they're thinking about that. And then if you were paying attention last fall, they were talking about how there are all these restaurants in China and Japan that are starting to use robots in terms of some of these service jobs that people are in. And I don't have a sense of how much beyond novelty this is at this point, but certainly we need to be thinking about also these types of service work that can be automated. What are the implications for that now? Like first of all, we've lost all our retail, and now you're going to go to a restaurant and everything's roboticized. When are we going to be interacting with people? And in some sense, that might be happening in other sectors already, but for these types of physical services that we're not used to, it's worth thinking about what the implication is for the designs of our cities and our commercial spaces. And I think the last one I wanted to talk about is robotics for daily living. So you may have seen, and I see these on TV every once in a while in different TV shows, these kinds of telepresence robots. So people who don't go into the office, they have these robots kind of roaming around for them that are supposed to be their eyes and ears in the office. And what's interesting, so hoteling is starting to become more and more popular as commercial space within cities gets more expensive. Large organizations start to think about how they can reduce their real estate footprints inside cities, so they have people working from home and only coming in when they really need to. So they have these sort of flexible spots that's nobody's permanent desk. It's just sort of a semi-permanent desk that you use when you show up. And so even further than that, once telepresence becomes more and more, so nobody's going to be at the office. They're going to be all these like robot things kind of running around in our eyes and ears. It's an interesting thing to think about. So this is by double. It's about $2,500, but there are other models that are significantly less expensive and other modes that perhaps are not as expensive or roboticized that might do the trick. But what's the implication when even knowledge work or sort of more the type of work that happens in North America, finance and that kind of thing starts to be mediated by these kinds of telepresence robots? What happens to the way we work. Telemedicine, so what happens when even our doctors are coming in by robot? What's the implication for our healthcare system and the way we live with healthcare? This is the neurosurgery robot in sort of larger form. So what happens when the doctor doesn't even have to be there for the neurosurgery or for the surgery itself? So what does that mean? I mean, lots of people live in cities in order to access these kinds of things that are not available in remote areas. And so what will that mean for the way we live in cities? And then finally, what happens when we live at home on our own longer, presumably because these robots can help us take care of ourselves. Robots like Brian that are going to remind us when to brush our teeth and when to take our medication and when we should go for a walk, and the fact that we've left the fridge open and how to like turn the heat up or down. And then this little robot called Pero, who is a companion robot for the elderly. So when our kids don't even have to come and see us anymore, because we have robots to say hi and to snuggle with. So I think all of these have implications for how we live and work and how we connect with each other. And so being in the city maybe is not just about the structures, but certainly the relationships within that city. And so a robotic-mediated city is going to be an interesting one. And I think that's all I'm going to talk. You can always reach me at this information, and you can find us on our website at getyourboton.com. Please, if this interests you, please join us, and certainly we can start the discussion, I guess.